moles revision and exam technique. First, we'll look at some definitions that you need to know for this topic. The first one is a mole is the amount of any substance containing as many particles as there are carbon atoms and exactly 12 grams of the carbon-12 isotope. These definitions are very useful, and if you learn them off by heart, an easy way to pick up marks in an exam. Another definition which is very important is the Avogadro constant. You need to remember that the Avogadro constant is equal to the number of particles in a mole, and that is equal to this number, 6.02 times 10 to the 23. Another definition is the molar mass, which is the mass per mole of substance. To work out the molar mass of anything, you use the periodic table. So, for example, the molar mass of a sodium atom, you would look it up on the periodic table, which is 23. If you wanted to work out the molar mass of water, again, you use the periodic table, look for the atomic mass of hydrogen, which is 1. There's 2 of those, so you times that by 2. And then add that on to the atomic mass of oxygen, which is 16. So the molar mass of water then is 18. Another definition which is very important is the molar volume. So the molar volume is the volume per mole of any gas at room temperature and pressure. And the molar volume of any gas is 24 litres. So if you have 1 mole of any gas, it's 24 litres, or 24,000 centimetre cubed. Okay, so what we're going to do now is we're going to look at some example questions and see how to answer them. Now, before you can answer any moles questions in chemistry, you need to learn the 4 equations, which are shown here in the triangle form. You need to be happy using these equations, rearranging them as well. If you don't know these equations, then obviously you will find the exam questions and test questions very, very difficult indeed. So here they are. We've got the Avogadro's equation, the mass equation, the gas volume equation, and the concentration equation. Okay, so let's have a look at this example question. We need to calculate the number of moles in these different amounts of chemicals. And when you're answering a question like this, the first thing you need to do is try and decide which equation you're going to use. And the only way you can do that is by looking at what information is given in the question. So we need to work out the moles, but we are given for a mass, and we have a formula. Now, the only equation which lets us use masses in grams is this one. So that is the equation we are going to use. So to answer question 1a, this is the equation we'll use. Calculate the number of moles in 2 grams of hydrochloric acid. So if we rearrange this equation, the number of moles then is equal to the mass divided by the molar mass. Now, the mass is obviously given in the question. Notice it's in grams. Now, if it was in kilograms, you would have to convert it into grams by multiplying by 1,000. This one's given in grams though. So the molar mass then, this is where you use your periodic table. If you look up hydrogen, there's an atomic mass of 1. Chlorine has got an atomic mass of 35.5. So the molar mass for this will be 36.5. So the final answer is 0.0548 moles. Okay, the next question. We need to calculate the number of moles in 48 centimeter cubed of hydrogen. Now, the first thing we need to do is decide which equation we can actually use. We have got this number, 48 centimeter cubed. Now, that relates to a gas, hydrogen as a gas. So this must be a volume. So the only equation we can use which talks about volumes of gases is the molar volume equation, which is this one here. So that's the equation that we need to use. So we've got the volume of hydrogen. We want to work out the moles. So rearranging the equation then, the equation tells us that we must do the volume in litres. It must always be in litres, divided by the molar volume, which is 24 litres. Now our volume here is in centimetres cubed. So you can convert that into litres by dividing by 1,000. Or you can use the alternative form of this equation, which is the volume measured in centimetres cubed divided by 24,000 centimetres cubed. So the answer will be 48 divided by 24,000. Which is 0.002 moles. Okay, and then on to C. Calculate the number of moles in 15 centimeter cubed of 0.2 moles per litre of sulfuric acid solution. Okay, so which equation do we use? Well, again, we've got this number in centimeters cubed. We've also got this number, which is the unit for which is moles per litre. And the question is about a solution. So we've got a concentration here. This is the unit for concentration. And this is a volume, but it's not a volume of a gas, it's a volume of a solution. So the only equation we can use which has concentration and volume of solutions is this one, the concentration equation. So rearranging this equation, if we want to work out the number of moles, we would multiply the concentration by the volume. And the volume must be in litres or decimeters. So the concentration of the sulfuric acid is 0.2. Multiply that by the volume. Now 15 centimeters cubed, we need to convert that into litres, so we do that by dividing by 1,000. The answer is 0.003 moles. Okay, this next question is asking for the number of particles in 100 grams of calcium oxide. So which equation do we use? Well, we need to work out the number of particles, so we will need to use at some stage this equation here, which we can use to work out the number of particles. Now, the only information we've got to use is the mass and a formula for calcium oxide. Now, from the formula, we can get the molar mass. So we have a mass in grams and a molar mass. So the other equation we can use is the mass equation. So which equation do we use first? Well, we have to use the mass equation first because that is the one we have the information for. So to calculate the number of particles, we need to work out the moles first. We can get the moles by doing the mass divided by the molar mass of calcium oxide, which is 56.1. That gives us the number of moles of 1.78. Okay, so now we have the number of moles. The question actually wanted the number of particles. So to work out the number of particles, we must use this equation. We have the moles, so to work out the number of particles, it is the moles multiplied by Avogadro's number. So 1.78 moles multiplied by Avogadro's constant gives us the total number of particles. Now, when you're inputting the numbers into your calculator, just make sure that you put Avogadro's constant in brackets to ensure that the calculator works properly. Okay, this next question asks, what mass of chlorine will be required to react with 5 grams of aluminium? Okay, so we are after the mass of the chlorine. So the mass of the chlorine is what we're trying to find out. We have got some information though. We have a mass of aluminium. So we know that we start with 5 grams of aluminium. So where do we start? Well, we have to start with the information that we've been given. So we've got 5 grams of aluminium, so that's where we must start. The only equation we can use is one with a mass of grams and perhaps the molar mass as well, which we can look up from the periodic table. So this is the equation we're going to use. So to work out the moles of aluminium, we would do the mass in grams divided by the molar mass for aluminium, which if you look it up in your periodic table is 27. I can just point out at this stage we do not use the coefficient, the big number in front. That is not what you use in this equation here. So if we do the calculation, we get 0.185 moles of aluminium. Okay, so now we know the number of moles of aluminium. How do we actually get to the moles of chlorine? Well, if you ever get a question where you know about one chemical, you don't know about one of the other chemicals in the balanced equation, this is when we actually use the coefficients, that's the big numbers in front, to work out a ratio. The ratio for aluminium to chlorine is 2 to 3. So, if we know the number of moles of aluminium, we need to scale it up by this factor. So how do we get from 2 to 3? Well, the one way you could do it is by multiplying by 1.5. Or another way you could do it is by dividing by 2 and then multiplying by 3. This is using the ratio. It's up to you which way you do it. So to work out the number of moles of chlorine, we get the number of moles of aluminium and scale it to give us the number of moles of chlorine. So the number of moles of chlorine is 0.28 moles. So that's fine, but the question does want us to work out the mass of chlorine. So if we look back at the equation, to work out the mass of something, we must do the moles multiplied by the molar mass. So we know the moles of chlorine and the molar mass of chlorine we can get from the periodic table. There are 2 chlorine atoms in chlorine. Each chlorine atom has a mass of 35.5, so the molar mass of Cl2 will be 71. So your final answer is 19.9 grams of chlorine. Okay, the next question wants us to calculate the volume of hydrogen gas made when we start off with 12 grams of sodium, which reacts with water. So we've got 12 grams of sodium, and it's the volume of hydrogen that we need to figure out. So where do we start? Well, you must always start with the information you've been given. So we've got 12 grams of sodium, so it's this equation that we must use. So to work out the number of moles of sodium, we will do the mass in grams divided by the molar mass. So the mass in grams is 12. The molar mass for sodium is 23 from the periodic table, and that gives us 0.52 moles of sodium. Okay, now the question wants us to work out the volume of hydrogen gas made. So we know about the sodium. How do we get to the hydrogen gas? Again, at this stage, you use the coefficients, the big numbers in front. We have a 2 in front of the sodium, and there isn't a number in front of the hydrogen, so we can assume that that is 1. So we always use these ratios then to work out the unknown chemical. The ratio here is 2 to 1. To go from 2 to 1, the easiest way is to divide by 2. So if we want to get to the number of moles of hydrogen, we get the number of moles of sodium, divide by 2. And that is equal to 0.26 moles of hydrogen. Now the question wants the volume of hydrogen gas made. So now we must use the gas volume equation. We've got the number of moles of hydrogen, but we want the volume of hydrogen made. So we rearrange the equation. To work out the volume of hydrogen gas made, it's the number of moles multiplied by the molar volume. Now the molar volume, remember, is the volume of any gas at room temperature pressure, which is 24 litres. So to work out the volume of hydrogen gas made, we'll get the number of moles and multiply that by 24. The final answer is 6.24 litres. Okay, next question. We're asked to calculate the volume of a 0.01 moles per litre hydrochloric acid, which is needed to react fully with 100 centimetre cubed of 0.2 moles per litre magnesium hydroxide solution. So this is a lot of information in this question. So we need to be very careful how we deal with all the information we've got. This is what we're trying to figure out, the volume of hydrochloric acid. So that's what we are trying to figure out. We don't know the volume of hydrochloric acid. But we have got some information about the hydrochloric acid, which we've got its concentration, which is 0.01 moles per litre. Now, the magnesium hydroxide we know a bit more information about. We know its volume and we know its concentration. Now, can I just point out that both of these chemicals are solutions, so even though we see this unit for volume, we are not using the gas equation. Okay, we're dealing with solutions. Okay, so for the magnesium hydroxide, we have 100 centimeter cube volume, and its concentration is 0.2 moles per liter. Okay, so where do we start? Well, in the moles calculation, we always start with the chemical that we have most of the information for, and that's the magnesium hydroxide. So we can forget about the hydrochloric acid for now. But the magnesium hydroxide, the magnesium hydroxide has a volume of 100 centimeters cubed and a concentration of 0.2 moles per liter. So if we've got a volume and a concentration, we must use the concentration equation. So rearranging this to work out the number of moles of magnesium hydroxide, we would do the concentration multiplied by the volume. Now remember, the volume here is given in centimeters cubed. We must use litres. So to convert centimeters cubed into litres, divide by 1,000. And that's equal to 0.02 moles of magnesium hydroxide. Okay, now to work out the volume of the acid, uh, we need a bit more information. We've got the concentration of the acid. To work out the volume of the acid, we need the moles. How do I know that? Well, if you look at the equation over here, if you have the concentration and you want to work out the volume, then you need the other factor in the equation, which is the number of moles. Now we know the number of moles of magnesium hydroxide. So how do we get to the moles of hydrochloric acid? Well, yet again, it's there in a balanced equation. We look at the big numbers in front, the ratio. So the ratio of magnesium hydroxide to hydrochloric acid is 1 to 2. So the ratio is 1 to 2. So how do we go from 1 to 2? The easiest way by multiplying by 2. So the number of moles of magnesium hydroxide multiplied by 2 will give us the number of moles of hydrochloric acid. Okay, finally, then we need to work out the volume of the acid. So by rearranging the equation, if we know the number of moles, divide that by the concentration, that will give us the volume. So the number of moles of the acid is 0.04. Divide that by the concentration, that will give us the number of moles. Sorry, the number of moles of hydrochloric acid divided by the concentration will give us the volume. Now remember, it's a solution, so this is the volume of the hydrochloric acid. The answer will come out in litres. Okay, this next question is asking for, talking about a standard solution. So a standard solution of sodium hydroxide is needed. The concentration required is 0.5 moles per litre, and the volume required is 250 centimetre cubed. What mass of sodium hydroxide must be used to make the standard solution? Okay, so where do we start? Well, this is what we're after. We're after a mass of sodium hydroxide. Now, there's the formula for sodium hydroxide. So if we're trying to work out the mass, we have at least got the molar mass. Well, that's all we've got. So all we've got here is the molar mass. We haven't got any of the other two. So we can't use this equation yet, but over here we've got a concentration and we've got a volume for this solution. So we can use this equation. If we have the concentration and the volume, we can work out the number of moles, which is equal to the concentration multiplied by the volume. And remember, the volume for um, solutions must always be in litres, so convert by divided by 1,000. And that's equal to 0.125 moles of sodium hydroxide. Now we've got the number of moles, and earlier we said we have got the molar mass, so now we can use this equation to work out the mass. So to work out the mass, it's the number of moles multiplied by the molar mass for sodium hydroxide, which is 40. So the final answer is 5 grams. Okay, this next question is talking about graphite. So in the 16th century, a large deposit of graphite was discovered in the Lake District. People at the time thought that graphite was a form of lead. Nowadays, graphite is used in pencils, but people still call it pencil lead. A student decided to investigate the number of carbon atoms in a pencil lead. He found that the mass of the pencil lead was 0.321 grams. Okay, so we need to calculate the amount in moles of carbon atoms in the student's pencil lead. It says assume that the pencil lead is pure graphite. Now before we go any further, let's just clarify what graphite is. Graphite is an allotrope of carbon, so basically it's the element carbon. Okay, now what information have we actually got in this question? Well, we've got a mass in grams. We know that we're talking about carbon. We need to work out the number of moles. So if we've got a mass in grams, we know that we're dealing with carbon. We can look at its molar mass up in the periodic table. We can use this equation then to work out the number of moles. So the number of moles will be 0.321 divided by 12. And the answer is 0.0268 moles. The next part of the question says, using the Avogadro constant, which you need to learn, calculate the number of carbon atoms in the student's pencil lead. Okay, so we know the number of moles of carbon, and we know what you should know, the Avogadro constant, and so we are going to use this equation here. To work out the number of particles, then it's the number of moles multiplied by 6.02 times 10 to the 23. Just remember to put that in brackets in your calculator. And there's your final answer. Okay, next question. It says calcium carbonate reacts with hydrochloric acid as shown in the equation below. And we know the number of moles of calcium carbonate that reacts with this concentration of hydrochloric acid. And we've got to calculate the volume in centimetre cubed of the 0.2 moles per litre hydrochloric acid required to react with 7.5 times 10 to the minus 3 moles of calcium carbonate. Okay, so the question wants us to work out the volume in centimetre cubed of the acid. Now, the acid is a solution. We want to work out the volume. We know the concentration. So let's have a look at the concentration equation. We know the concentration, but we don't know the volume. To get to the volume, then we need the number of moles. So how can we get to the number of moles of hydrochloric acid? Well, we know the number of moles of calcium carbonate. So if we're trying to find out about the acid, we need to use the ratio. And the ratio is 1 to 2. So that means if we know the number of moles of calcium carbonate, if we times the number of moles of calcium carbonate by 2, that will give us the number of moles of hydrochloric acid. So the number of moles of calcium carbonate is that. Put brackets around it in your calculator. Multiply it by 2. So the number of moles of the acid is 0.015 moles. Okay. Now to work out the volume, what have we got? For the hydrochloric acid, we've got the concentration. So we've got the concentration, we've got the number of moles. So now we can work out the volume. So that is the number of moles, which is 0.015, divided by the concentration, which is 0.2, which is equal to 0.075. Now that answer is in litres. It's in litres because it's come from a concentration which is measured in moles per litre, but the answer is required in centimetre cubed. So you must convert the litres into centimetre cubed by multiplying by 1,000. And the answer, 0.075 times by 1,000, is 75 centimetres cubed. Next part of the question says, calculate the volume in centimetres cubed of carbon dioxide formed at room temperature and pressure. Okay, so it's the carbon dioxide we need to find out about. So what information have we got? Well, we haven't got any information about the carbon dioxide at all. But we have got a number of moles for calcium carbonate. There's calcium carbonate. Now, yet again, if you want to find out about another chemical in a balanced equation, you must use the ratio. And the ratio here, look, is 1 to 1. So that means if we start off with this number of moles of calcium carbonate, that number of moles will be the same as the number of moles of carbon dioxide, which is 7.5 times 10 to the minus 3. So once we've got the number of moles, we can try and figure out the volume. This is a gas, so we're going to use the molar volume for gases equation. So if we want to work out the volume, it's the number of moles multiplied by the molar volume. So we get this number, make sure it's in brackets in your calculator, and multiply it by the molar volume. Now, the molar volume is 24 litres. However, we want the answer in centimetres cubed. So remember, 24 litres is equal to 24,000 centimetre cubed. And if you do that calculation, the answer is 180 centimetres cubed.